This video lesson will be about solving equations that have variables on both sides of the equal sign, and that may also include brackets. So in some equations, you have variables on both sides of the equal sign. In order to solve, you have to put all your variables on one side of the equation and then solve it so that all of the numbers are on the other side of the equation. Some people prefer to have their variables on the left-hand side, like an x equals. Some people move their variables to whichever side makes them positive because they want a positive variable. It doesn't matter how you do it as long as your variables are together. So let's take a look at our first example. For this example, a plus 5 equals negative 5a plus 5. So we can see that we have a's on both sides of this equation. We have a single a over here and we have a negative 5a over here. So there's two ways that we can do this. We can either take this negative 5a, get rid of it, and move it to the other side. In that case, all of the a's will be on the left and they'll be positive. But I could also take this single a and subtract it from this side, and it will pop up over here, making all of my a's on the right side, but they'll be negative. So both ways work, and we're going to do both to show you how those work. So let's get a pen here. So we'll do this way first. If we add a to both sides, add 5a to both sides. So I'm going to start with my equation. A plus 5 equals negative 5a plus 5. I'm going to draw my line down here to keep everything nice and neat. So if I want to get rid of this negative 5a, I'm going to add 5a. Okay, because I have a negative 5a, I can add 5a, and those cancel out. You'll remember that from our unit on polynomials, how we can combine terms that have the same variable and same degree. So a negative 5a and a positive 5a cancel out to 0. So when we do that, we have to do it to the other side. So it essentially moves this 5a over to the other side so that it can be with the other a. Okay, so we're going to rewrite our equation of what we have left. This a plus 5a, we now have 6a on this side, and the plus 5 didn't go anywhere, equals these 5a's cancel out, the negative and the positive, and we're left with just 5 on this side. So now we have just a regular two-step equation that we can solve. We would take away 5 next, because we want to deal with anything that's not closest to the variable first. Okay, so the negative 5 and the positive 5 cancel out on the left, leaving me with just 6a. 5 minus 5 leaves me with 0. And then we divide by 6 to get rid of this, multiply 6. Divide 0 by both sides, so we're left with a equals 0 as an answer. Okay, so let's try it the other way and see if it works out to the same answer. So in the first way that we did it, we added 5a to both sides in order to move this 5a over to the other side so that we had all our a's on the left. This time we're going to move all our a's to the right-hand side. So we have our equation, a plus 5 equals negative 5a plus 5. I'm going to draw my line. All right, so this time I want to move all my a's over here to the right-hand side. So I need to get rid of this a by subtracting an a. I have 1a and I'm subtracting 1a. But if I subtract a from one side, I have to subtract a from the other side as well. So these ones cancel out, they make a 0 pair, and I'm left with just 5. And on this side, I have a negative 5a, take away another a. So it's like I have $5 in debt and I lose one more dollar. So now I am $6 in debt, or I have negative 6a plus 5. So you can see all we're doing here is we are combining these like terms. Okay, we're putting these together. Negative 5a plus a negative a, or a negative 5a subtract an a. And this is what we're left with. Again, a two-step equation. So we're going to get rid of this 5 next because we want to isolate our variable. So we do it to both sides. These cancel out to make a 0 pair, and I'm left on this side with just a negative 6a. On this side we have 5 minus 5, which is 0. Okay, so all we have left to do is to get rid of this negative 6. So I divide by negative 6 because it's the opposite of multiplying. And those cancel out, and I divide by negative 6. And I have 0 on this side, and I'm left with an a on this side. So we do get the exact same answer. So it doesn't matter what way you do it. Some people like to keep their a's always positive, so they move the variables over in a way that's going to leave them with a positive variable. Some people just like to have them on the right-hand side or the left-hand side, so it really doesn't matter as long as they're all together on one side, and then you solve. So let's try one more example here. We have 5x plus 6 equals 2x plus 24. So we have x's on both sides. We want to get all the x's onto one side. So I usually like to have them on the right-hand side, but even more than that, I like them to be positive. So I know if I move this 5x, I'm going to have to subtract 5x, and it's going to leave me with a negative x on this side. So I'm going to move this, oops, try that again, this 2x over to the other side. So I'm going to subtract 2x because this is a positive 2x. So to make a 0 pair and to get rid of it, I need to subtract 2x. I do the opposite operation. But if I do it to one side, I have to do it to the other. Okay, so on my left-hand side, I combine these two like terms. 5x subtract 2x leaves me with 3x. And of course, the plus 6, which I haven't changed. These cancel out, and on the left-hand side, I'm left with 24. And now I have a basic two-step equation. So I will subtract 6 from both sides. These cancel out, leaving me with just 3x on this side. 24 minus 6 leaves me with 18. And then because this is a 3 multiplied by x, I'm going to do the inverse, or the opposite, and I'm going to divide by 3 on both sides. So I end up with x equals 18 divided by 3, which is 6. And here's my answer. Okay, I do want to verify just to make sure that I have the right answer. So this is the first time we've verified where we have variables on both sides of our equation. So all you're going to do, same as before, is you're going to replace every x with a 6. And then you're going to work out or calculate both sides of the equation and see if they equal each other at the end. So here we have 5 multiplied by 6 plus 6 equals 2 multiplied by 6 plus 24. So all I've done is taken that x and I've put in or substituted in a 6 instead, because that's the answer I found. Now I need to see when I work these out using order of operations on each side, do the two sides equal? So we're not going to move things from one side to the other. We're just going to calculate the left side and calculate the right side and see if they equal. So 5 times 6 is 30. I do my multiplication first when I'm using BEDMAS. And then I can do my addition. 30 plus 6 is 36. So I have 36 on the left-hand side. Now let's calculate the right-hand side. 2 times 6 is 12. Okay, and then 12 plus 24 is 36. So I know that my answer is correct because both sides of the equation are equal. So when x is 6, then this statement is true. In some equations, you are going to need to use the distributive property first to multiply out the brackets and to simplify this before you can actually solve it. We call that cleaning up. So we're going to clean this up a little bit, and then we can better solve our equation. So I'm going to draw my line down the page. So I'm not going to do anything right now to the left-hand side, but I am going to use the distributive property to multiply this out and expand it. So 6 times 1 gives me 6. 6 times a positive 3k gives me positive 18k. Okay, now I have an equation with variables on both sides. So I need to decide, am I going to move my 18k over to this side with the negative 6k, or am I going to move the negative 6k over to this side? Like I said, I always like to have positive variables. So I'm going to move this negative 6k over to this side. So by doing that, I need to add 6k. So when I add 6k to both sides, I can see that my variables are going to cancel out on this side, leaving me with just negative 18. But on the right-hand side, they're going to be a positive number. I always like to have positive numbers for my variables. So 18 plus 6 is going to be 24. Okay. Okay, now we just have again a basic two-step equation. So we want to get the k by itself. So we need to get rid of this 6 first, anything that's furthest away from the variable. So we'll subtract 6. This is a positive 6, so we need to subtract 6 to make a 0 pair. And we also subtract 6 from this side. So negative 18, you're $18 in debt, and you lose $6 more. You're now at negative 24. And on this side, we have left just a 24k. Okay, so now to get rid of this 24, this is a 24 multiplied by k, so we do the inverse or the opposite to get rid of it, and we divide by 24. Those cancel out. We have to do the same to this side, divide by 24. And we're left with negative 24 divided by 24 is just negative 1 equals k. So that's our answer. But of course, we should verify it. So again, all we're going to do, wherever there's a k in our equation, we're going to substitute in a negative 1. So everything else in the equation remains exactly the same. But wherever there's a k, you put brackets and put a negative 1. 1 plus 3, negative 1. Can have two sets of brackets there, but that's okay. All right, and again, we are working out the left and right side independently to see if they end up with the same answer at the end. We have to use our order of operations. So I'm going to start with this part right here. And I'm going to calculate negative 6 times negative 1. That's what I'm going to do first because I want to do my multiplication first. So negative 6 multiplied by negative 1 equals a positive 6. Okay, and now I can do my subtraction or my addition here. Negative 18 plus 6 is, of course, negative 12. Okay, so I end up with negative 12 on my left side. So I want to see what I have on my right side. So using order of operations, I'm going to do brackets first. Okay, and inside my brackets, I am going to do the multiplication first. So 3 times negative 1. So this 1 stays, and I'll do the 3 times negative 1, which gives me a negative 3. Okay, I still have some brackets here. So 6, and then 1 minus 3 is negative 2. Now I can do my multiplication. 6 times negative 2 is negative 12. So you can see I do end up with the same answer on both sides, which means that my answer of k equals -1 is correct. So our last example has variables on both sides, but we actually have the distributive property on both sides of our equation. So we need to multiply out these brackets on both sides before we can proceed and try to solve. So let's do that. 3 times x is 3x. Whoops. 3x. And then 3 times a -4. Remember, we have to include that sign in front of the constant. So 3 times a -4 is -12. Okay, so that's what we have on one side of my equation. 2 times a -2x is a -4x. And 2 times a +1 is a +2. Okay, so now we have just variables on both sides. We need to decide if we're going to move all of our variables to the right-hand side or to the left-hand side. So I'm going to move them all to the right-hand side because I know they'll be positive that way. So if I need to move this -4x and move it over to the right-hand side, then I need to get rid of it over here by adding 4x. Okay, that would make a 0 pair. -4x plus 4x equals 0. And I'm going to add 4x over to this side as well. So I'll rewrite my equation. I combine my like terms here, 3x plus 4x. Now I have 7x. And my subtract 12 doesn't change any. So over here, this has crossed out into a 0 pair. All I'm left with is 2. And now we just have a two-step equation. So I will add 12 to both sides and rewrite what I have left. I've got a 7x on the left. 2 plus 12 gives me 14 on the right. And now I need to get rid of this 7. Because it is a 7 multiplied by x, I'll do the inverse to get rid of it, and I'll divide by 7. So I divide the other side also by 7, and I'm left with x equals 2. 14 divided by 7 is 2. So there's my answer. Now let's verify. So we always start just by writing down our question to verify. Make sure you do copy it exactly. And I'm going to work out my left and right hand side independently. So wherever there's an x, I'm going to put in a 2 instead, because that's the answer I found. And I want to see if I put 2 into this equation, does it make it true? Do both sides actually equal like the equation says? So wherever there's an x, I'm putting in a 2 in brackets. I didn't use brackets here, but you can. More important here because it's multiplying. So let's start with our left-hand side. Using order of operations, we need to solve our brackets first. So 2 minus 4 is -2. And then 3 multiplied by -2 gives me -6 on my left-hand side. So now let's work out our right-hand side. We've got our brackets that we have to do first. And inside the brackets, we have multiplying and we have adding. So inside the brackets, we need to start with the multiplying first. Okay, so that -2 times 2. Everything else is going to stay the same. -2 times 2 is -4. Keep our +1. Now let's finish off our brackets. -4 plus 1 is -3. And now we can do 2 times -3, which is -6. Okay, so you can see that, yes, both sides of my equation are equal when I substitute a 2 in for the x. So my answer is correct.